little details that you may not have thought of. Okay, so page 49. I have different types of regressions, and I call the first one type 0, okay? Type 0, the points are just simply provided to you. You don't have to come up with any points yourself. So let's read this question. An airplane performs a stunt in an air show. It consists of a sudden drop followed by a rapid increase in height. The stunt ends when the plane reaches its initial altitude. The table below shows the heights at different times. I think that is worth highlighting. If the question explicitly tells you when something is done, it means that afterwards we stop graphing. We do no longer consider anything afterwards, okay? If you have a table like this, guaranteed the first row is going to be going into L1. The second row is going to be going into L2. So technically, these are our x and our y values that we're entering. So grab your calculators, regardless of where you're at, and make sure you type that in, okay? I have a bunch of stuff in my, so I'm going to clear everything that I have here. Okay, there we go, and type that in. So 2, 6, 8, 15. And it's 750. 315, 210, 433, 13, right? You double check, take the extra 15 seconds and double check if you've typed everything in correctly, because if you're off by even one number, everything goes down the drain, right? Everything is wrong afterwards. So it says, determine the equation that models the height of the plane over time. So they want the equation. So we're going to give that to this question, right? So the way I ask you to answer this is as follows. You go A here, and then you'll simply say stat, calculate, quadratic regression. And that's the bare minimum that I ask you to do. And then you just go y is equal to, and you type in, you actually write down the equation. Page 49. So let's go perform the regression all together. So stat, calculate, we go quadratic regression, hit enter. Then it's second 1, comma, second 2, comma, alpha trace to call up y1. So we want to paste it into y1 and hit equals. Before, hold on, I want to say something here. I hope you remember this. If there's an e to the negative anything, you have to be careful. You do not want to just write down the numbers, because if especially c, if there's an e to the negative 12, it's a very small number. It's 0 for us. Okay, we do not include it. If it is e to the negative 4, that's a different story. That actually will just shift the decimal over 4 places. It doesn't happen in this course, but next year it may happen. So you don't have to worry about that too much. So this is 9.38 x squared minus 183.75x plus 1,080. Okay? That is the equation. That is what we want for A. Write that down. Okay? For B, it's asking for the initial height of the plane at the start of the stunt. Happens at y-intercept. Right? This happens at the y-intercept. So when time is equal to 0, what is that height that we're after? Okay, that's what this is asking. So we're going to go second, trace, value. We're going to let x equal to 0. And some of you already realized, Mr. Dirksen, it's 1,080. That's the y-intercept. Yes, you are correct. But this leads me to the graph now. Okay, if you want to do this, you need to make sure your graph actually has everything you need. So let's hit graph at this time. Oh, I didn't do the zoom stat, right? Zoom stat, I didn't do that, so I'm not going to see anything. I'm going to go make sure plot 1 is turned on, and then you press zoom and zoom 9 or zoom stat. And it gives you a pretty good picture of what's happening. The plane drops, reaches the lowest altitude, and then goes back up. But the window is your problem here. Okay, you need to adjust your window. Press window and make sure that your x-min and your y-min are negatives. So y-min is going to be -5, let's say, and y-min is also going to be -5. Okay, x-min, y-min, negative, something negative in there. Then hit graph again to see how these changes affect. Right, so now you see the y-axis and you see the x-axis, so that's better. We still need to see the y-intercept. We know this is going to cross the y-axis here, so I'm going to change. What do I need to change to make that happen? Y max, right? So window, Y max, I'm going to go 1500. And there you see it crossing. That is important, okay? So perfect. Let's go find that y-intercept, second trace value. X is equal to 0. Y is equal to 1080. So 1080, what are we in with height? It's feet, right?
Excuse the interruption. All grade 12 students who need their
All right. So it's 1080. That's our initial height. Okay, so that's answers question B. How long did the stunt last? Highlight this. Right, this one is a little trickier maybe than. We know that it stops. Like if you go back to your question, the stunt ends when the plane reaches the initial altitude. So when it gets back to 1080. Okay. So what I'm going to do is I'm going to go y equals. I'm going to let y2 equal 1080. And so I know it starts there and it ends when it gets back to that height. For me to see it, I need to change my window a little bit. I'm going to change my x max to, let's say 40. Let's see if that works. There we go. And there. So the stunt starts at 1080, drops, goes back to 1080. So we know it ends right there. Okay, so for C, I'm going to give you a little bit of a diagram here. 1080 back to 1080, right? So this is the 1080 mark, okay? So it ends there. Let's go find that intersection, okay? So once you have that on your window, you go second trace, intersect. I'm going to go closest to that one. It's 19.6, 1080. Okay. So 19.6, 1080. So we know that the first number represents how long it takes to go from here to there. That's when a stunt ends. So it lasted 19.60 seconds. Because time is measured in seconds here, so that's how you do that one. What was the plane's lowest height? What are we going to find there? We're finding the vertex, right? The lowest point. So we're going to go second, trace, min. Let's go find that. Second trace minimum. You go to the left of it, go to the right of it, enter, enter. So that is the vertex. I'm going to write everything down because you're going to need it for your graph anyways. Okay, so you might as well just copy the whole thing down. 9.80 and 179.63 is the coordinate of that vertex. So this is the height though, right? 179.63 feet is the lowest height this plane ever reaches. So if I answered that, E, graph this scenario. Okay, I'm going to tell you something about graphing with points given. You may choose to use the points or use the vertex, the intercepts, and other points that you found. Okay, I prefer using the points that I found because it makes it easier to see the whole picture. Because the one I gave you only gives you a couple, you don't see the whole picture. So, what do you need for a good graph? Labels. So this is time in seconds. This is height in feet. Right? And I know that the stunt ends after 19.6 seconds, right? Right here. It ends when it goes back to that initial height. So I need to make sure I have enough room for that. So I'm going to try this. 5, 10, 15, 20, 25. That'll work pretty good. And then for the y-axis, I need to go all the way up to 1,080. So let's see how that's going to work. 200, 400, 600, 800, 1,000. This would be 1,200. So I'm going up by 200 there. This is 1,100 right here. So 1,080 is just under. And then at 19.6, I'm going back to 1,080. So I should be at the same height right there. The vertex is at 179.63, 9.8. So 9.8, this is 9, sorry, this is 7.5. 9.8 is somewhere here. And you go all the way to 179. This is 100, 150, 179 is right about there. And you sketch it. Make sure you have your equation. 9.38x squared minus 183.75x plus 1,080. That is your graph. There should be no arrowheads going backwards or past it because it ends there. So this quadratic equation we come is only valid for this stretch right here up until when you get back to that stunt. Because I'm guessing the plane is going to do this, right? It's going to fly at a constant height afterwards. So it's kind of like it's just valid for this stretch. So the graph is done. Let's come up with the domain and range. What would you say the domain is? It's from time 0, right? You got to go to your x-axis. 0 to 19.60. That's it. Okay. For the range, what's the lowest it ever reaches? It's determined by the vertex, right? So the y value of the vertex is 179.63. So this should be 179.63. And the highest point in this case is 1,080, right? That's basically where it starts and where it ends. So smallest, largest, always in that order. Okay. G. G is a little trickier. It's asking for at or above 800 meters, 800 feet, right? I kind of didn't leave a whole lot of room here, so let's do this. Graph this real quick. This is the 800 meter line right here. If you find this time here and this time there and you subtract them, make sure you pay attention to this part. If you subtract these two times, what are you going to find? You're going to find the time that the plane spent below the 800 mark. Okay? But we're going to find those anyways. I'll show you what else we'll do here. This is time 1. This is time 2. Let's figure out time 1. Use your calculator. You let, I should have done the keystrokes here. Y2 is equal to 800. And then we're going to go second, trace, intersect. Okay. So I'm going to change my Y2 to 800. Then I'm going to hit graph. And there's the 800 foot line, right? So I'm going to find this intersection and that intersection. That would be a good start to this investigation here. You know what? I'm going to do this one right away. I'm here already. Enter, enter, enter. Time 2, this is time 2 for me, is 17.9346. And then time 1, you go over to this side, enter, enter, enter. That one is 1.6653. Those are my 2 times there. If I subtract them, if I go T2 minus T1, I'm getting, watch this part here, this is going to be 16.2693. Grab a different color highlighter. What you found here, oof, this one is no good anymore. Even more. You found the time spent below 800, but it wants to know above. So how would you find the time spent above 800, given the information that you already have? What's the total time this stunt lasted? 19.6, right? If we subtract the 16 seconds from the 19.6, right, we're going to be left with the time spent above it. So that's my approach here. Time above is 1960 minus 16.2693. And you get 3 seconds and 3.33 seconds, I should say. That is the time above. So that's getting a different color. That's going to give me that stretch right there and that stretch right there. Okay. So tight. I will just make a note here. Time below is this. Therefore, time above is taking away the time below from the other. You may have done it a different way. It doesn't matter to me how you find it. You just have to be careful what you do there. Okay? So I started off maybe with a question that asks a lot, right? But that way you kind of have a bit of an understanding of what can you expect, okay? So I will say this. I want you to start in class, okay? So page 50 all the way to 51. So it's just 2 questions, but it's enough to get you started with this type of scenario.